Why do large systems, companies, institutions, governments, so often fail to see the very problems that eventually cause their collapse?
The common assumption we all make is that organizations are built to collect information. We believe that critical data from the front lines naturally flows upward to decision makers, but this intuitive model is fundamentally incorrect.
The reality is that the structure of a large system is designed to filter information, not transmit it. The system doesn't see certain problems because its very architecture actively prevents it from doing so.
To see how this works, let's track a simple, concrete example. Imagine an operator working deep inside a complex machine. They notice a new, slight vibration. It's minor, but it's definitely there. To understand why that vibration goes unseen, we first have to break the system down into its two fundamental roles. This is where the initial gap in perception is born.
First, you have the principal. Think of this as a manager or a leader. Their role is to set high-level goals, increase output, meet a quarterly target, deliver a service. They don't do the work themselves, they delegate it.
Second, you have the agent. This is the person on the ground, the one actually performing the task. Because they are doing the work, they hold all the direct local knowledge about what's really happening.
Now, this separation is absolutely critical. It means the principal and the agent exist in entirely different information worlds. The data they see and interact with is fundamentally different.
This gap has a formal name: information asymmetry. It's simply a condition where one party, in this case the agent, has more and better information than the other. And it's important to understand this isn't a flaw in the system, it's an inherent, unavoidable feature of delegation.
So our operator, the agent, experiences the system through direct sensory data. They can feel the vibration. This is rich, real-time information, but it's also unquantified and subjective. The manager, our principal, sees something completely different. They don't see vibrations. They see spreadsheets, performance reports, and production metrics. Their reality is abstract, aggregated, and historical. In their world, the vibration doesn't even exist.
This natural information gap isn't just a passive void. It becomes an active filter the moment the system introduces incentives. All of a sudden, seeing a problem becomes costly for the person who sees it.
This dynamic creates something called the principal-agent problem. It's a conflict of interest that happens when what's best for the agent isn't the same as what's best for the principal. The system creates a wedge between what it desires and what it rewards. An agent isn't being negligent when they follow their incentives. They are being perfectly rational. A system communicates what is truly important through the rewards it offers, and people respond logically to that signal. For example, the agent's incentive might be to maximize a simple, measurable output, like units produced per hour. But the principal's true goal is much broader, the long-term health and stability of the entire system. And those two goals are often not the same.
So, when an agent has information that could disrupt their measured output, their most rational choice is often silence. Reporting a problem is a personal risk. It invites scrutiny, it creates more work, and it threatens their performance metrics. Silence is the safe, rewarded path.
For our operator, there is no incentive to report that slight vibration. Doing so means shutting down the machine, falling behind on quota, and filling out paperwork. It's purely unrewarded, costly work. The rational decision is to ignore it and keep the line moving.
But here's the next step. These individual, rational choices have structural consequences. Repeated acts of silence begin to physically change the procedures and architecture of the system itself.
You see, each time an operator rationally chooses silence, a signal is sent back to the system. Everything is fine. This repeated non-reporting isn't a neutral act. It actively shapes the organization's understanding of its own health. This creates a feedback loop that solidifies the blindness. First, local data like the vibration is withheld. Second, the system's high-level metrics continue to look good. Third, the system logically concludes that this kind of low-level data must be irrelevant noise. And finally, the formal channels for reporting it are removed for efficiency, or they simply fall into disuse.
The result is profound. The system is now structurally blind. It no longer possesses the sensors or the pathways to see that kind of problem. It hasn't just missed the information, it has lost the very capacity to receive it.
This structural blindness creates the perfect conditions for systemic failure.
When small, unseen problems are allowed to accumulate inside a complex system, the result is a specific type of failure that always appears to be sudden. The sociologist Charles Perrow called this a normal accident. His key insight was that in highly complex and tightly coupled systems, major failures are not abnormal events. They are a normal and, in fact, inevitable outcome of the system's own properties.
So the unseen vibration gets worse over time, causing wear on a hidden component. This weakened part then interacts with another small unseen issue, a brief power fluctuation, for instance. The two minor events cascade into a catastrophic failure. From the manager's perspective, the disaster seems to come out of nowhere, completely unavoidable. But it wasn't.
This whole process shows us how a system can meticulously design its own catastrophe. The cause is not malice or incompetence, but a series of individually logical steps.
Here is the central paradox. The system's blindness is not a bug, but a feature. It is the direct result of the system optimizing for what it measures and rewards. To maximize a metric like production efficiency, the system must rationally filter out any information it deems irrelevant or costly, like a minor vibration.
In the end, a series of perfectly rational, efficient decisions at the local level accumulates into a deeply irrational and disastrous outcome at the global level. Systems don't fail because individuals make mistakes. They fail because individuals, acting logically within the rules of the system, do exactly what they're supposed to do.